So let's let me begin then. Consciousness. There are all kinds of different problems with consciousness, and it's one of the great unsolved problems of all time, and no one really understands how consciousness works, and there's lots of crazy ideas about it. And I think for that reason, one of my heroes, John Searle from the States, who's a philosopher in the mind, he strongly advises researchers not to work on consciousness, at least not until they've got tenure anyway, is how he put it. And I'm not exactly sure what tenure is, but I'm pretty sure I haven't got it. But I have reached the kind of age now where it really doesn't matter to me, so I can indulge myself a little on some things. And I can look at problems which I'm really interested in, rather than problems which I'm, say, paid to be interested in. And the hard problem of consciousness is one of those many problems. So, before I begin, let me just lay down some ground rules for you that I can make that clear. I'm coming at this from a realist position. Okay, so in other words, I take it for granted that there is a real world out there, and the real world exists independently of the human mind. And this real world is external to us, and it doesn't depend upon us for its existence, and it's there, whether we're conscious or whether we're not conscious. And reality is there, and it's been there before any of us existed, and it's going to continue to be there long after life on this tiny planet has ceased to exist. Now, that, from my point of view, I regard as absolutely basic, and I consider it a condition of philosophical sanity to hold views like that. There are many people nowadays that deny it, and it's common to take a view that everything is answerable. Instead of making everything answerable to the world, that they make the world answerable to their state of consciousness. But I'm not going to go into that. I'm just taking for granted then realism as a fundamental viewpoint. So that's where I'm coming from. So let's look at the hard problem of consciousness. What about the hard problem? If we talk about hard problem, then that implies there must be some easy problems, and there are hard problems and easy problems in consciousness. And it was David Chalmers, who is working in the other end of the world, in Canada, not Canada, in Australia, where he was the first really not to distinguish between hard problems and easy problems, but rather to make it most public. So, and he said he never expected it to take off the way it did, because he certainly made a name for himself by identifying the hard problem as opposed to the easy problem. So, what is that clearly? Let's just have a look at that. The hard problem, as distinguished from the easy problems are things about the brain, essentially, and brain states, and how, for example, sensory data is processed by the brain. And they are essentially functionally defined here. If we can find some kind of function of the brain that performs these particular tasks, like transmitting pain or seeing how neurons work, then he says that this is what we call the easy problems. Now, you might disagree with him in the sense that they're jolly hard to solve, but they are solvable in principle. They are solvable, they're functionally, as I say, defined. But the hard problem is in a different kind of category, and it sort of makes it hard. Not that the easy problems are easy in the sense that we can easily come up with an answer. We may take a lot of work and hard effort to get the solution to the easy problems, but the hard problem is not functionally definable. And the question is like, how does consciousness actually arise? When you look at something, why do you perceive a redness there? And where does that sensation of redness or that experience of redness come from? Where does the feeling of pain come from? And how does the brain produce those kind of subjective experiences? That, he says, is the hard problem. And let's just look at one particular example of that. Let me take the color yellow as an example of a particular sensation. Okay, so let's examine that. The easy problems are, say, a function you find. Let's look at the yellow problem. Let's call it the hard yellow problem, if you like, and let's try and pin it down and understand it a little bit better. There you go. There is a yellow screen. You sit in front of a yellow screen. It's got nothing but yellow on it, and all you can see is yellow. And the hard problem asks you, where does that experience of yellow come from that's in your head? Now, as someone's already said, I'm a physicist. I come from a physics background, and we know from physics that in the real world, light is impinging upon our eyes, and light is composed of electromagnetic waves. Some of those waves have got a longer wavelength, which corresponds to a kind of red colors. Some of them have got a shorter wavelength, and it corresponds to the more violet end of the spectrum. And the light from the yellow screen, that corresponds to electromagnetic waves with a wavelength of around about 570 nanometers. Okay, but wavelength is a distance. It is not a color. Wavelength doesn't have a color. So the question then is, where does the yellowness come from? Where does the yellow sensation come from? The wave of 570 nanometers enters your eye. It's refracted by the lens. It's brought to focus on the retina, and it impinges at the back of the eye there on the retina. And on in the cells of the back of the retina, there are different cone receptor cells which give you sensations of color. 3 different kinds of cones which respond to slightly different wavelengths of light. And the green and the red cone centers are activated by this yellow light, and they then produce electrical impulses, which are then fed along your optic nerve to neurons in the brain. And then the brain then combines these electric impulses in such a way as to register as yellow light. But the question here is, right along this pathway, where did the electromagnetic wavelength of 570 nanometers get turned into the experience of yellow? Because there's no yellow in the 570 nanometers, nor is there any yellow in the lens, and nor is there any yellow in the retina, nor in the cone receptor cells, which are just cells. And neither can the electric impulses which are fed to the brain be said to carry yellowness, to carry electrical impulses. That's all. So where does the sensation of yellow come from? And somehow or other, in a way that we don't know and don't understand at the moment, it is constructed inside the brain that we don't have a theory about. And all we can say at the moment is that the brain turns these electrical signals into a sensation, which we all experience, of this yellow, seeing yellow. So what physics tells us then is there is no color in the real world. When I see a yellow sensation, or when I see a green thing, which is another sensation, then these sensations are entirely in my mind, constructed by my mind. There is no color in the outside world. The outside world is just a wavelength of electromagnetic wave radiation. And every person manufactures their own color, and we don't know how. Okay. But the problem is a bit deeper than this. And it's deeper for this reason. We can't even assume that everybody has the same sensation, that the yellow that I perceive is the same sensation that you perceive, because no 2 brains are the same. Physiologically, every single brain is different from every other brain. Might have the same structures, but the wiring is entirely different. It's been grown organically, and the neuron assignment is different, and therefore there is no reason to suppose that one brain perceives the same things as another brain in the same way. So your yellow might be green to me, and it's very possible that it is a different color to me, because you have different wiring than I do. We don't know how that impacts upon the sensation. But usually we can agree despite those particular differences, but the brains are different. But we don't always necessarily agree. Let me give you another example. Here's something which you may recognize. What color is the dress? Well, this is a viral phenomenon that went viral in the internet about 2015. Viewers of this particular image of the dress that you can just see there disagree on whether the dress depicted in that photograph is either coloured blue and black or whether it's white and gold. And I mean, I happen to know personally it's white and gold, but I'm told that there are other people who believe it's completely different from me, that it's blue and black. And this phenomenon reveals the differences in human colour perception. And we're not exactly sure what causes that at the moment. And there are scientific investigations into neuroscience and vision science, which produce a number of papers on this very topic in many journals as such. But that still shows that there are different perceptions that people have. This is how the thing actually looks apparently in bright sunlight, which means it tends to be a black and blue dress, despite it appearing in the picture as white and gold. Okay, so we have a problem, a hard problem of consciousness. It's where do our experiences come from? And can we get some explanation, or can we construct some model of them somehow or other? Now, my contention today, and the thing I'm going to try to present to you, is that no, we can't do that. And it's not that it's just too difficult a problem to solve, but my contention is that it is in principle impossible to solve this. It's my contention that the hard problem of consciousness will never be solved. And I want to try to persuade you of that and present my reasons for it in the short time that we have left. But to do that, I'm afraid you've got to take you with me backward. I've got to back up quite a bit, and I have to take you back to Locke and Berkeley and Hume and around about the 1700s or thereabouts, just to indicate to you the nature of this problem and how we come about trying to solve it and how it's trying to be solved. Here is a picture of George Berkeley, a dapper looking young fellow on the left hand side, and you can see by his ecclesiastical dress that he was a cleric in the Church of England. In fact, they didn't have such fancy costumes as the clergy have today, if you saw them in the coronation, but that was a rather plain black and white one that he had. But he was a bishop, and he's often called Bishop Berkeley. And he's the Berkeley that Berkeley in California is named after, and even Berkeley University is named after. They're all named after this guy. So he's a man of some influence and understanding. And he's written a few books on this particular matter. He's written this treatise on the principles of human knowledge. And he concluded that everything comes to us through our perceptions, that all that we know, in fact, are our perceptions, and there is nothing else in the world except our perceptions. That was his argument. In fact, he made quite a stir with that argument, and many people around that time were debating, particularly in the coffee houses and the other places, exactly whether Berkeley was right to say that the only things we perceive are our perceptions. We don't have, therefore, any ground for saying there's anything in the world which is substantial other than the perceptions that we have. And there's even a reference to his debate with Johnson. Common sense ridicules Berkeley's idea that there's no real things out in the world. And this was Boswell and Johnson. And Boswell points out that they debated this issue of Bishop Berkeley and what he called ingenious sophistry to prove the non-existence of matter. Only perceptions exist, and that the universe is just a merely ideal thing. And Johnson was asked if he could refute it, because Boswell thought it was impossible to refute the idea. And Johnson, in his typical Johnson way, just simply kicked a mighty force against a stone on the ground till his foot rebounded and said, "I refute him thus." Well, typical Johnson, but of course that didn't refute Berkeley at all, because, well, the pain in your toe, well, that's just another more sensation. And it doesn't indicate that the world is not just made out of sensations. Nevertheless, common sense rebels against the idea that the world is nothing more than just the fact that we're all living in a Matrix movie, which is the idea that Berkeley originally put forward. This was picked up by Locke and made a little bit more solid. No man's knowledge here can go beyond his experience. So he's moving into the realm of knowledge now. What can we know about the world outside? It's not just about our experiences, but Locke is, I suppose, the father of empiricism is what he's called here. He says that all knowledge comes from the senses, and you can't know anything except what you can experience. That's his point. And he's making the point that you don't know if someone sees the same thing, that same yellow that you might see. They might see a different kind of yellow. As he spoke about violets and marigolds in one of his passages, and said that we can never know that if someone who looks at a violet, which is a violet color, there's no way of knowing that whether the thing which he sees or the color that that person sees is any different from what someone else might see when they look at a marigold, which is a yellow or orangey color. He said you cannot tell the difference between the two. You cannot do it even now or ever. And it's not possible, he said, to know that, because you can't put your mind inside the mind of somebody else to find out exactly how they perceive things. So that was Locke's approach, taking it a little step further until we get to David Hume. And David Hume was an empiricist here, and you can also see he was a pioneer in fashionable hats as well. As an empiricist, he believed that all knowledge is derived exclusively from the senses and from nothing else. But Hume has pointed out that if you are an empiricist, then you have a couple of problems. And he laid out these problems in such a way that there was no real solution to them. The first problem, he said, was that if all of our knowledge comes from sense data, then he said, what exactly is substance? In other words, what is yellow, for example? If you try to imagine substance apart from sense data or separated from sense data, you find yourself looking at, well, absolutely nothing at all, is basically his point. So it follows that there is no substance that we can know. It's entirely created by our minds, said David Hume. And the second problem he went on to point out is that if knowledge comes from sense data, then there's no basis either for thinking that one thing causes another thing either. In other words, the scientific empirical basis for causation is gone. There's no basis for that either. Now, these kind of ideas, that the world outside you is created entirely inside your own mind, we would normally dismiss this as absurd and ridiculous, especially if Hume had just thrown out the idea for speculation or discussion. But he didn't. He was making a watertight case for this. That was the point. And although we have to throw out Hume's conclusion that there is nothing real that we can hold on to, unfortunately, Hume has arrived at his points in such a way that it's impossible to throw out his argument without abandoning empirical reasoning itself. This is how he did it. Let me just give you a clue. What he said was this. He said, all the knowledge that we know of the world, or where any knowledge ever comes from, is of two kinds only, and only two kinds. All knowledge is either analytic or it is synthetic. And by analytic, he meant things which are true by definition. And for example, we can make a statement like bachelors are unmarried men, spinsters are unmarried women, 1 + 1 = 2, 5 + 7 = 12, the theorem of Pythagoras. All of these things are true by definition. In other words, the opposite would be self-contradictory. The opposites can't sustain themselves. It's about relations of ideas. On the other hand, he said, the other kind of knowledge that we have is synthetic knowledge. This is knowledge which comes to us through experience. So, for example, looking around my room here, I can say there were 12 chairs in the room, or 6 or whatever. I can say my dog's got fleas, or the sun was going to rise next Wednesday. And these are all things which we can know through experience. These are matters of fact. And it's possible to find the opposite. It might be that there's only 4 chairs in the room rather than 12, whatever it may be. But his point is that genuine knowledge cannot come through the analytic, because it's true by definition, no knowledge of the outside world anyway. And only genuine knowledge can come through synthetic statements. But synthetic statements only come through the senses. You cannot build objective knowledge out of sense data. It's particular to you. As Hume put it one time, he said, I never catch myself at any time without a perception. I can never observe anything but a perception. And that's a statement which is very hard to disagree with. So let's come back to our problem. Starting from our subjective experience, starting from the human mind, how do we bridge the gap to get to objective knowledge or knowledge of the real world? How do we get across the gap there? Well, there are 2 routes, says Hume. There's the analytic route and the synthetic route. And you cannot do it through the analytic route because that tells you nothing new about the world. It's true by definition. It doesn't tell you anything about the real world. So he blocks that one off. And then he says, secondly, you can't obtain any real knowledge from synthetic knowledge either, because all you've got is your sense data. You don't have substance. You only have perceptions of the real world. You don't have the real world itself. So you can't have any objective knowledge at all, and he blocks off that route as well. Now, as I say, if you think it's an amusing argument that Hume was just throwing it out for fun, then we haven't really understood it, because Hume, as I say, was making a watertight case here. And there is no way, he said, to obtain objective knowledge. He's just ruled it out and he shut the door. Enter our next character. Enter Kant. Immanuel Kant. This is Immanuel Kant here. Apparently his habits were so regular you could set the town clock by when he left for his morning walk. And he said that he found that Hume's argument was so disconcerting that it famously shocked him out of his dogmatic slumbers, he said in 1793. Now, Kant sought to try to find a way around Hume's problem, and he wrote probably the most famous philosophy book of all time in order to answer it, and that was The Critique of Pure Reason. So Kant took the view that knowledge from experience is not enough by itself. You also need to have knowledge from reason. Now, knowledge from experience he called a posteriori knowledge. For example, this guy is 24 years old, and knowledge which came from reason he called a priori knowledge. This man is a male, this woman is a female. Now, the first is true from experience, and the second is independent of experience. So let's have a look at how he put it this way. So synthetic knowledge, he said, well, we'll still agree that analytic knowledge is not going to give us anything new, but synthetic knowledge you can divide up now into 2 different kinds. You've got synthetic a priori knowledge, a priori coming from before experience, and the synthetic a posteriori knowledge. That's a posteriori coming after experience. And he divides it up in this way. And he says that the synthetic a priori knowledge, the stuff which comes to you from before experience, such as these kind of things. He said that space and time is a kind of framework which we intuitively know, and when we find information from the world around us from a posteriori knowledge, we can put it into that framework of time and space. Causality is another part of the synthetic a priori, but also arithmetic, mathematics is synthetic a priori, theorem of Pythagoras, shortest distance between 2 points, geometry, all of that. It's knowledge which is known by reason alone, independent of experience, but when you add it to the experience you have a framework which will give you a route to objective knowledge. So this is the key idea of Kant. That is, that all these things are justified, for example, maths and geometry, not on the ground of sensory input, but on the ground of this synthetic a priori knowledge. So his approach to this was like this. He said, okay, Hume has blocked off our routes to gain objective knowledge, but I want to divide up synthetic knowledge into the a priori type and the a posteriori type. The a posteriori is something which I agree can still be blocked by Hume's argument because it still comes through our senses. But the a priori type is something which is real knowledge about the world, and which we can use our synthetic knowledge to attach to that in order to make sure that we can start to construct objective knowledge. So by finding this kind of loophole, which is what the book is, the first part of the book is firstly about, Kant claims to have solved the problem that we were presented with. And Kant's solution then is that objective knowledge comes from the synthetic a priori route. Makes that thing. Well, it didn't take too long before the solution of the synthetic a priori was rather doubted and objected by a range of different people. Bertrand Russell thought it was an interesting solution, but not a valid one. He put it that way, a kind of damned by faint praise approach to it. A.J. Ayer, another famous philosopher, wrote a very influential book, Language, Truth and Knowledge, reckoned that synthetic a priori knowledge was at best a tautology, like 1 + 1 = 2. It doesn't tell you anything else. So he dismissed it as well. Fiegel, he said quite bluntly, he repudiated the whole thing. All forms of empiricism agree in repudiating the existence of it. He didn't have much hope for that. Schlick, he also said synthetic a priori knowledge was, according to him, a logical impossibility. And Hans Reichenbach, he also said that Kant didn't quite see the weak spot of the construction, the way which he put it. So he also dismissed it. So you still have today people taking both sides. It's not a proper solution to our problem of subjective experience, because it's rejected by many people, accepted by some, but probably rejected by most, I would think. So with that kind of response, we now find we've got a situation whereby even that route is, at least for the most part, blocked by many arguments, and we can say at least that it's a contested route and hasn't really solved the problem. Okay, so where does that leave us then? Well, I wanted to suggest to you that I've got a different approach to it, which I hope might at least spur some suggestions that this might be a different way of solving this particular problem. So the approach is based upon 2 assumptions which I want to make, and I want to declare my assumptions right at the very start. I hope you'll think that the assumptions are obvious and straightforward and quite unobjectionable. But let's see what you think of them. My first principle, my first assumption, is that the observer is part of reality. The observer O is part of the real world. The observer does not stand outside of the universe which is being observed. The observer is part of the universe and subject to the same representations. Therefore, if we're going to represent the universe or represent sense data, represent what we perceive, then the observer is part of that representation. And I think that's a principle which is not only reasonable, but I think it's been supported by and emphasized by quantum theory. I hate to dip back into my past in that kind of way, but I think it's been incorporated in that theory in a fundamental level where we're told that the observer is part of the universe, and even to the point that the observer affects the thing that's being observed, as you probably are aware. Anyway, that's my first principle. The observer is part of the real world and therefore needs to be represented within the real world, not separate. And principle number 2 is that observers are functionally independent of each other. What do I mean by that? What I mean is that each observer has got their own perceptions, and we cannot know if the perception of one is the same as the perception of another. This is like John Locke's principle here, that they're independent, functionally independent, in the sense that you cannot put yourself inside somebody's head to see how they see something. So, and I've expressed that in this kind of mathematical formalism, which basically says that there does not exist any function which will take you from observer 1 point of view to observer's 2 point of view, or there's no function which exists which will take you from observer 2 to observer 1. You could think of it as vectors, if you like, as well. We'll look at that in a moment. Now, my contention is that from these 2 principles, it's possible to demonstrate 2 things. Firstly, that objectivity or objective knowledge can be constructed from subjective perceptions. And secondly, that objective knowledge is founded upon relative knowledge, as I hope we'll see. And from those 2 conclusions, it then follows, as I hope to make my point at the end, that the hard problem of consciousness can therefore never be solved. Okay. Now, before I do that, I just have to run the concept of turn to the concept of objectivity and try to make that a little bit tighter and make the definition of it a little bit more operationally precise. Otherwise, we can't incorporate that into our scheme of things. So there's John Searle, and he made the point that the notion of subjective and objective massively confused in philosophy. I quite agree with him, because the meaning of the word objective is not always clear to different people. There are apparently 9 different definitions in the Oxford English Dictionary for objective, and you can easily glide between them without meaning to while you're holding a definition together. And it's not clear how to represent objectivity mathematically, and I think I need to do that. So I want to tighten up the definition, or rather make it operational, so we can cast it in a form which is measurable and unambiguous. And I intend to do that by introducing a new term, which I'm going to call transitive or transitivity. So I want to enter that word. The word transitive simply means that something here, a property or observation, can be transferred between observers unambiguously and without any change. So transitive knowledge is therefore agreed knowledge. We can agree that we can have this knowledge in common, if such a thing exists. That's how I want to define it. So it can be shared between all observers, and it does not depend on a particular point of view. Now you might say, well, that knowledge might not exist. Well, it may not, but we'll see how we get on. But consequently, transitive knowledge would then form building blocks of that collective body of knowledge that we might call science, or we might call it objective knowledge. And so in this way, what I'm claiming is that transitive is really the core property of being objective, in the sense that it's the foundation of the independence of objective knowledge, which is shareable. So I'm going to define for you the difference between transitive and non-transitive phenomenon. Let's have a look and see if I can put that together, just to make it clear. So transitivity, just to clarify, is that property which can be shared unambiguously between observers. Transitive sort of literally means to go across. So we can use the term strictly to mean it's that quality or quantity, if you like, can go across from one observer to another observer unchanged. Now, that I would say is the essential quality that's behind objectivity, that's required to build scientific knowledge, because without any transitivity, there can be no transferable knowledge. There can be no building of knowledge. There can be no agreement about what you're talking about, no repository of knowledge which can be common to all. So it's in this transitive sense that we talk about objective knowledge. So if some phenomena, I've called them Ri, are transitive, that would then mean that all the observers would see and agree the same thing. So I've put a little equation there saying that if an observer OJ is looking at some phenomenon Ri, and some other observer OK is looking at the same phenomenon, then they are equal. They are the same, and they can be equated, because that's what it means to be shared between them. They are equivalent. On the other hand, if phenomena are not transitive, then we would express that in this way, that non-transitive phenomena is such that there is no equality which can be drawn, that you cannot say that the two things are equal. It's impossible in principle. Now, with those things fairly clear, I hope we will be able to build a world out of some sense data. So let me, as I say, taking a realistic point of view, let me jump to sense representation. How do we represent our senses? Well, the sense data that we have comes from our senses, and it was Aristotle who many years ago, about 350 BC, tutor of Alexander the Great. He was the one who was the first person to classify the senses. Did it in a fairly straightforward and primitive way. He determined that there were 5 senses: sight, hearing, taste, smell, and touch, which we all get taught as children in schools. But more careful investigations has led us to today to, some people say there were 13 senses, some say there were 26, some other people say there were 30, some people say there were more than 50. There is actually no consensus on the matter of how many different senses there are, but I've got here a list of some of the ones which are most commonly agreed. I'm not sure you can read them. So they fall into groups like vision. You can see intensity of light and color of light, of which there were 3 dimensions for color. There's shape, of which there would be 2 dimensions, because that's the 2-dimensional retina. There's location as well, which is 3 dimensions for location, because you've got your 2 dimensions for the retina, but you've also got accommodation for having 2 eyes, so you can see some idea of depth, and movement too. So there was a number of dimensions required to represent vision. And similarly, the same is true with hearing. You can determine amplitude, how loud or how soft the sound is, or the frequency, whether it's a high note or a low note. These are simple one-dimensional things. And direction, you can determine direction: up, down, left, right, far away, close by, because you've got 2 ears, so that helps to determine direction, and so on. I'm not going to go through all of those, but there was lots of different senses producing lots of different kinds of data. Okay, how would we represent those different kinds of data? Well, we can use a representation space. Now, a representation space means that we can allocate, if you like, a dimension to every single one of those sense data. And mathematically, that makes no difference here. For a quantum physicist such as myself, who's used to dealing with Hilbert spaces, where they have an infinite number of dimensions, this is a small problem. It's not an issue. So we can have a 20, 30, 40, 50 dimensional space that we can represent in some way, some hyperdimensional space where we can generously allocate each sense datum its own dimension measured over the real field. So we can look at it like this if you like. I'm going to represent all the ones there. I've left out the interceptors at the bottom there because they're internal sensors looking at the external world. So you could say that the human body is part of the external world, and it is, of course, but it doesn't matter. I'm just taking a sample of those kind of sensors. I can represent them in this kind of way, where the ket, the Ri ket, is a hyperdimensional representation of a vector for anything which we might be perceived. Got various components for it. I can't represent a hyperdimensional space. There's my poor effort at trying to do so. You have to imagine that normally we can do 3 dimensions on 2 pieces of paper with a bit of perspective, but here I've thrown in a few more dimensions. They're all orthogonal to each other, and they all represent a different independent dimension in space. And we can have as many of those as we like. In fact, I'm only going to simplify that down for you because we don't need to do the whole big thing. We can just take a simple subset of all of this. So let's, and of course, this is just one of many approaches. I'm not saying this is the only way of representing sense data. You can represent it in probably 100 different ways. I'm just using vectors here as a convenience to point out something about invariance. So here's one way of representing color, for example. There's many different ways of representing color. I've just chosen RGB, red, green, blue, as a space, a representation space. And a colored point, a point in the space would represent a particular color in a vector, such as the C ket, will be given by 3 parameters RGB, and the point there is determining where we are in this representational space. Okay. Now, from our assumption 1, we will move on to the point that the observer is part of the real world. Remember, that was our first assumption. And therefore, we can locate the observer, or need to link our observer to the representational space. And we're going to bring the observer in to do that, maybe a couple of observers to look at that color. And from assumption 2, another observer, which would have an independent location in representational space, would be completely independent of observer 1. That was our second assumption. So our picture now looks like this. What we've got here is we've introduced observers with their own spaces, their own disjoint vector spaces. I've called it O1 and O2, where each observer has got their own perception space, which is unknown and has an unknown relation to the other observer. I've drawn a vector there, R12, which links them together. But in principle, R12 can't be known, according to assumption 2. That's indeterminate. But we can form these representational spaces together into a joint vector space, if you like. You can take a joint by adding the C space to O1 space and to O2 space, extending your vectors out further, and then you've got a large perception or representation space. Now, if you look at that diagram, look at the left-hand corner, observer 1 is observing the color C, and their perception of that color C is given by, let's say, the value of the vector R1. Hope you can see that there. And that links it to the property C, the yellow color, to the observer R1. And the perception by observer 1, if you can see at the top left-hand corner there, is O1 perceives C as being equal to R1. And then the second observer on O2 on the right-hand side there, that's got its own vector, representational vector, a perception vector, which we call R2. And therefore, we now have two different perceptions of the same color. Now, each observer, say, has got their own perception of color C, represented by R1 on one case and R2 on the other case. And it is impossible to compare the perceptions of the two observers because they inhabit their own perceptual subspace. And we can't relate R1 to R2 because we need to know R1 too. You can see I can represent R1 in terms of R2 by simple vector addition. That's why we've used a vector space here as a representation. It's quite easy to do it this way. And R1 is equal to R2 plus R1 too. And that's fine. And you can say, well, I can now perceive R1 in terms of R2. I can see what the other person is seeing, except that the fact that assumption number 2 was that R12 cannot be determined. And because R12 cannot be determined, the thing which links the two observers, therefore you cannot get any way of representing R1 in terms of R2. In other words, you cannot see what the observer 1 is seeing when they see yellow, and you cannot understand what O2 is seeing when they see yellow. That's because they are, therefore, we will call that non-transitive. For every observer that you might have, when they're looking at a property of some kind, then they cannot be equated, or they cannot even be related to each other in any particular way. So, and that's what I call the perception of absolute qualities. They can't be linked together. So we can't relate 1 or 2. It's impossible to represent R1 in terms of R2. Enter Henri Poincaré. He's another of my favorite heroes from the 19th century. He was almost managed to pick up relativity and present relativity just before Einstein. So insightful was he, but he didn't quite make it. Einstein got there just before him, but he was pretty close on. Anyway, he said, and with quite perception, the aim of science is not things in themselves, as the dogmatists in their simplicity imagine, but the relation between things. He was the first to point out the importance of relative quantities. We cannot measure absolute quantities. We can only know and understand and measure relative quantities, says Poincaré. So let's turn to relative quantities and see how they are affected. Now, what I've done is I've replaced the color point with a relative quantity, which is given by the vector S here. You can think of the relative vector S. You can imagine, say, one end of that vector of S is yellow and the other end is blue, say. So it's linking two different colors. Doesn't matter as long as they're different, whatever you want to think of it. Now, observer O1 perceives S as the difference between the two vectors, R1 minus R dashed 1. And O2 perceives S, the difference between the two qualities, as the difference between two vectors, R2 minus R dashed 2. So, and you can see that from the equations I've put there. So their perception now of a relative difference is given by the difference between those two qualities. These are relative qualities, and that's quite different as the difference of two absolutes. Okay. Now, as a consequence of this, let's just do some very simple methods, nothing very complicated about this at all. But because we're now dealing with relative qualities, you can now represent R1 in terms of R2. How does that magic work? Well, again, if you look on the left-hand side, you've got R1 equals R dashed 1 is equal to R dash 2 plus this undetermined vector R12, which we don't know from assumption 2. And we've got also R1 equals R2 plus, again, this indeterminate vector R12. But if we substitute into the expression for what O1 sees of the relative consequence, then you've got that equation down below, and you'll see that R-1 minus R1 is equal to, from the formulas above, we substitute those values in, and we get the R12 factor. It just drops out. It cancels out with a relative quantity. So in other words, the observer of O1 of S is now equated to the observation of O2 of S, but only, notice, for relative qualities. It's the perception of relative qualities which makes the difference here. So we now see that we meet the transitive requirement that there does exist for all observers, OJ or OK, that the observation of a relative quantity, R1 minus Ri minus R dashed I, can be equated now to another observer looking at the same quantity, so that we can say that they are now together. Coming quickly to the end, I know I'm running out of time here. Well, let me just quickly say, therefore, that the perception of absolute qualities is non-transitive, whereas the perception of relative qualities is transitive. That's the crucial thing here. And how does that affect our subjective knowledge experience? Well, whereas all the other avenues have been blocked, we now have absolute and relative elements that we can put onto the synthetic a posteriori. We can say that absolute values are blocked because they're intransitive, non-transitive, but the relative quantities are transitive. In other words, they are invariants of the observer system. They are invariants in the sense that it doesn't matter which observer is observing them. And this is something which I think provides us with a solution to get from subjective experience. Very quickly, back to the hard problem. We've shown that for the appearance of color on its own is an absolute value. That means it's non-transitive. Absolute values can't be transferred to another observer. Only relative values are transitive, such as the difference between two colors or different intensities of light. So absolute quantities are appended through a direct input into the sense organ. So the brightness of your light could be intense for one person, or it could be seen as dim for another. A sound can be considered loud by one person, while it can be considered soft for another. These are non-transitive, but the relative quantities are different. They are not apprehended by the sense organs directly. They're constructed from a comparison of direct perceptions, and that comparison is not performed by the sense organ. The relative comparison is made outside of the eye or the ear, for example, standing above perception and comparing the output of one with another. And so when we see a color, we can't be sure it's the same color, but when we compare one color with another color, or one light intensity with another light intensity, then all can agree that this is lighter and this is darker. This is brighter than this. This sound is louder than that. And on those relative quantities, we can start to construct some objective knowledge. Consequently, because the hard problem is about perceiving absolute quantities, they are always non-transitive. They are forever locked inside the head of each individual. They can never be discussed, explained, or shared with anyone else. And for that reason, the hard problem will never be solved, because it would involve sharing absolute values. We can't talk about them, we can't share them, but we can talk about and we can share the invariants of observation, which are relative quantities. There are other things, but we'll stop at that point because I've gone over time. My apologies for that. Let me return to our setup.